Hello everyone and welcome to the course Laplace Transformation. This is the first session of this course and we are going to learn all ins and outs of this really important topic through solving many problems. As you know, Laplace has a really crucial role in many branches of science and engineering, and therefore there are many students involved with this topic, and I hope the content that we're gonna talk about it through this course is also interesting for you. So to start our first session, I would like to tell you that Laplace is just one example of a topic that we usually call it linear transformation. Let me write it down here for you. Linear transformation. Transformation. So why we call it transformation? Because usually we have something like technically a function, and we are going to change it, like transfer it to a new environment, to a new space, to look at it from a new perspective. It's like we try to, or let me put it in this way. For example, let's think that we have a function like ft. So this is a function and the variable, let us think of it as time, okay? So we have a function of time and we are going to transfer this function is like, let me tell you something like that. I'm going, instead of t, I'm going to change this function or transfer this function and look at it with the new variable s. That means I don't want to think of or work on this function with the variable of, with the time as a variable, but I'd like to change the input variable and make it into a new one, which I call it s here. But how to do that? Using an integral. For example, let me put it here. This is my function ft, and I'm going to take an integral from minus infinity to plus infinity, right? But there's another function here. I can call it, for example, k, which k is a function of both of these variables. I mean, a function of both t and s, and then I'm going to take this integral with respect to t. So the answer of this integral definitely going to be a function of s. Why? Because I'm taking the integral on t, right? So there would be no t on the answer. We would only have s on the answer. So the answer of this integration going to be a new function, which is a function of variable s. This is actually the mathematical definition of Laplace. And if you look at this definition, we do have something here, which we usually call it the core or the kernel of this integration. So we have our main function here. We have the main function here. We have the core. Let me use another color here, gonna be more beautiful. So we have the core here, or the kernel. We have our main function, and we just have an integral. That's all. We don't have anything else. And a beautiful story is that not only the Laplace transformation, but most of other transformation, for instance, Fourier transformation, Z transformation, they are all like have a structure similar with this one. I mean, a core or a kernel times the main function, and we're gonna have an integral. And then this, as the whole, this is a transformation. This is an integral transformation. And this is going to give us a new function with a new variable. Instead of t, we're going to have the s. So this is the definition of Laplace transformation. But actually, the one that we are going to learn in this course and is really famous in engineering and science is a little like simpler than this one, because here we don't know exactly what the core function or the kernel function is, but I'm going to simplify it and show you what type of kernel function we are going to work on. So I'm going to simplify this one. K Ts equals, this gonna be 0 when t is less than 0. Well, if t is time, t is less than 0 doesn't make sense, right? So anyway, if it is t, then the answer of the Laplace transformation gonna also be 0. So let's think about the cases where t is greater or equal to 0. So in this case, then the function gonna be exponential of minus st. That's it. So right now, if I put this kernel function here into this integral, then like the answer gonna be something like integral of, we could even say 0 to plus infinity, right? So e to the minus st, and then we have our main function ft dt, and this is the definition of Laplace. So I can just write down here fs. This is the main definition of Laplace that we are going to work on it. So I can show you the Wikipedia page of this Laplace transformation. This guy here called Simon Laplace, he was a French mathematician like many years ago, maybe 200 or 300 years ago, who pioneered this really important topic in mathematics. And then later, after him, there was another smart guy called Heaviside, Oliver Heaviside. He was an English mathematician and physicist who also worked on this topic. And then right now we have the opportunity to enjoy the application of Laplace transformation. Okay, today we just wanted to like get familiar a bit with the form of the Laplace transformation and mathematical formulation of this transformation. From the next session on, we will be working on the like discussions around this topic, and at the same time try to solve some problems and make it more clear for you. See you next session.